In this video, we will be doing some additional examples for implicit differentiation. So let's say we have this equation and we want to implicitly differentiate it. We would first have to apply the chain rule for y plus 1 cubed. So this will give us 3 times y plus 1 to the power of 2 times, and now we have to find the derivative of the inner function. So the derivative of y is 1, and when we find the derivative of 1, we have to write dy over dx, and the derivative of 1 is simply 0, so we can leave it as is. And this is equal to the derivative of x squared, which is 2x. And our next step is to isolate dy over dx. So that gives us dy over dx, which is equal to 2x over 3y plus 1 squared. And this would be our final answer. In our next example, the derivative of 2x squared is equal to 4x plus the derivative of y squared is equal to 2y times dy over dx, and the derivative of 3 is equal to 0. So this gives us 2y dy over dx equal to minus 4x, and this simplifies to dy over dx equal to minus 4x over 2y, which simplifies further to dy over dx equal to minus 2x over y. And this is our final answer. For our next example, we have xy plus x equal to 7. And let's differentiate this implicitly. So first, let's find the derivative of x times y. So we would have to apply the product rule. So we have x times the derivative of y, which is equal to 1. And don't forget the dy over dx. Plus, now we have to find the derivative of x, which is equal to 1 times y plus, and now the derivative of x is equal to 1, and the derivative of 7 is equal to 0. And now let's isolate for dy over dx. So we have minus y minus 1, and on the other side we have x times dy over dx, and we could just isolate for dy over dx by dividing both sides by x. So that gives us minus y minus 1 over x. And this would be our final answer. In our next example, we have sine y equals x cubed. So the derivative of sine y is simply cosine y times dy over dx, and the derivative of x cubed is equal to 3x squared. And now let's isolate for dy over dx. So that gives us 3x squared over cosine y. And this is our final answer. For our next example, the derivative of ln y is 1 over y times dy over dx equal to, and the derivative of x squared is equal to 2x. And let's isolate for dy over dx, and this gives us 2xy as our final answer. In our next example, we have e to the xy plus y equal to x. So let's find the derivative of e to the xy. So that is equal to e to the xy times the derivative of x times y. So here we would have to apply the product rule. So that gives us x times the derivative of y, which is equal to 1, times dy over dx, plus the derivative of x, which is equal to 1, times y, plus, and now let's find the derivative of y, which is equal to 1 dy over dx, equal to the derivative of x, which is equal to 1. And now let's expand everything. So we have e to the xy times x dy over dx plus e to the xy times y. And now we have plus dy over dx equal to 1. And this is equal to e to the xy times x dy over dx plus dy over dx equal to 1 minus e to the xy times y. And finally, let's factor dy over dx. So we have dy over dx times e to the xy times x plus 1 equal to 1 minus e to the xy times y. And finally, this gives us dy over dx, which is equal to 1 minus e to the xy times y over e to the xy times x plus 1. And this would be our final answer. In our next example, we have ln x plus y. So the derivative of that is 1 over x plus y times the derivative of x plus y. So the derivative of x is equal to 1, and the derivative of y is equal to 1 times dy over dx. And this is equal to the derivative of x squared, which is equal to 2x. And now let's simplify everything. So let's move x plus y on the other side. So we have 2x times x plus y. And this gives us 1 plus dy over dx. And we can move the 1 on the other side. So this gives us dy over dx equal to 2x times x plus y minus 1. And this is our final answer. In our next example, the derivative of tan y is equal to secant y squared dy over dx, and this is equal to the derivative of x cubed, which is 3x squared, plus the derivative of y, which is equal to 1 dy over dx. And now this gives us secant y squared dy over dx minus dy over dx equal to 3x squared. And now let's factor out dy over dx. So we have dy over dx times secant y squared minus 1, and this is equal to 3x squared. And now let's isolate for dy over dx. So we have dy over dx equal to 3x squared over secant y squared minus 1. And this gives us our final answer. If you found this video helpful, please leave a like and subscribe to the channel, and thank you very much for watching.